Good day, everyone. You are welcome to another class. Today we are looking at the subject physics, and the topic is measurement of length. The definition of length. Length is defined as a measure of separation between 2 points, or you can say the distance between 2 points. So this length can be measured by either of the following methods, either by meter rule, by vernier caliper, micrometer, screw gauge. Other measuring devices include engineer's caliper, tape rule, and so on and so forth. We have so many of them. The use of a particular instrument depends on one. That's the use of either meter rule, vernier caliper, micrometer, screw gauge depends on this criteria. One, distance, size, and the shape of what to be measured must be put into consideration. Two is degree of accuracy. All the instruments used in measurement have a degree of accuracy. All must be put into consideration. So we're looking at the meter rule. The meter rule is a standard solid instrument which is either made of wood, steel, or plastic. It is graduated in centimeters and millimeters. Its degree of accuracy is 1 millimeter. 1 millimeter, or you can convert it to centimeter, because 1 millimeter is equivalent to 0.1 centimeter, and 1 centimeter is equivalent to 10 millimeter. So you can say 1 over 10 equals to this. So its degree of accuracy is either 1 millimeter or 0.1 centimeter, which is the smallest graduation of the meter rule, or least count of a meter rule. When we say smallest graduation or least count of a meter rule, it means that is the counting step. The counting begins in centimeter, 0.1. The next is 0.2, 0.3, and so on. But in millimeter, the counting begins with 1, the next 2 millimeter, 3 millimeter, and so on and so forth. So whether you begin your counting in millimeter or in centimeter, provided you start with 1 millimeter, the next is 2 millimeter, 3 millimeter. If you are counting in centimeter, it means you have to start with 0.1 as a least count. The next will be 0.2, 0.3, because we can see that 1 millimeter is the same thing as 0.1. So that is that with respect to meter rule. Includes the following: 1, zero error; 2, parallax error. These are the commonly found error or detected error with respect to meter rule. So we shall consider each of them one after the other, starting with zero error. The zero error occurs as a result of the damage done at the ends of the meter rule due to wear or negligence. This can be avoided by taking measurement at any convenient mark, say 2 centimeters away from the zero mark. The value obtained can then be subtracted from the final reading obtained. The above explanation can be expressed mathematically as follows. So, assuming that the measured reading of block is 8.10 centimeter, you must take note of the point that you started your counting. The point you started your counting is what you call corrected error. So it is known as length for zero error correction, and it's 2.00 centimeter. It's not necessary that you must start from 2.00. You can start from any point, but the most important thing is at the end of your measurement, you must subtract that value from the final reading. Now, after the subtraction, whatever is left is the actual reading of the measured length of that object. So based on what we have here now, the actual reading is 8.10 centimeter, and the corrected error point is 2.00 centimeter. So the actual reading of the block now is going to be 8.10 centimeter minus 2.00 centimeter. We can arrange it as 8.10 minus 2.00, all in what? Centimeter. Take note that before you can subtract or add the quantities must have the same unit before you can subtract or add. So we are subtracting because they have the same unit. So we have 8 minus 2 is what? 6. 1 minus 0 is 1. 0 minus 0 is 0. So the actual reading now is 6.10 centimeter of this block. 6.10 centimeter is the actual reading of this block. I said there are 2 errors associated with meter rule. Whenever you are using meter rule, you should bear in mind that 2 errors may likely take place. And the first we just talked about was 0 error. And this is the last one, parallax error. Parallax error occurs as a result of either 1, the thickness of the rule, 2, viewing the required point in a slanting position. We are going to see how we can view vertical position and horizontal position as we progress in this lesson. This should be avoided by ensuring that the eye is placed vertically above the mark to be read if the meter rule is placed horizontally. For vertical reading, the place eye horizontally along the level of the mark to be read. Now look at the practical illustration of what I just said here. You can see that this is a meter rule placed horizontally. Horizontal placement of meter rule. That's found in figure 1. Now, assuming that the actual point to be read using the meter rule is at this point 1, that's 1 centimeter rather. You are expected to place your eye above the mark that is indicated there, as you can see on the board. We have 3 different positions. The vertical position is the correct position to be viewed, while this position is incorrect. That is the slanting position we are talking about. This position is wrong. That is to say that the left and the right hand side are wrong. You are supposed to view it vertically. Once you are able to view it vertically, then this error will be avoided. But when you view it this way or this way, then you are incurring what we call parallax error. In a situation whereby you are measuring an object and the meter rule must be placed vertically, the reverse is the case in this condition. Looking at figure 2, you see that it's vertically placed and the point to be read is at this point 1. You are expected to view the point to be read in horizontal direction, not like the previous one, horizontal direction. But when you view it in this direction, as you can see, when you view it in this direction, you incur what we call parallax error. This direction is wrong. This direction is wrong. Once it's viewed in this direction, parallax error will take place. So you are advised to always ensure that you view what you read in a horizontal direction. If you are measuring vertically, as you can see in figure 2, and if you are measuring in horizontal direction, you are to view it in the vertical direction, as you can see on the board, in order to avoid parallax error. Because of course in physics errors are inevitable, but we try by all means to minimize it so as to achieve the end of what we want to derive at the end of our measurement. So the next video we are going to consider other measuring devices using micrometer, screw gauge and vernier calipers. There are also errors associated to such devices, which I want you to stay tuned as we look forward to the next video.